With the weather turning colder and more time spent inside, it's easy to forget that you need fresh air. To try and solve this problem, I created a robot that constantly threatens you if you keep all your windows closed. This has definitely resulted in fresher air, but an unfortunate increase in robot-related nightmares. I can't quite figure out what the deal is with that, but for now, I'm going to try something a little less intense. So instead, I present to you the F.L.O.W.E.R, or Floral Live Observer with Environmental Readings, a self-contained air quality sensor. This device will droop as the air quality drops, and then pop right back up when it improves. Part of this idea came to me when I saw a Kickstarter for a device called the Birdie. It's an electronic take on the canary that miners used to take with them into mines. I thought the device was super cool, and I wanted to try my own take on it. Since a canary was already taken, I went with the next best thing I could think of that can react to changes in the environment and settled on a flower. I broke the whole thing down into 3 phases. Phase 1 is the design of the electronics and coding. Phase 2 was the physical design of the plant pot and the flower mechanism. And Phase 3 was putting the whole thing together. I started with what would be easiest for me, which was the electronics design and coding. My first step was choosing an Arduino for the project. I looked around online and settled on the Arduino Nano. It's cheap, easy to use, and easy to program. I spent a little extra to get the fancy USB-C version, but any Nano, and for that matter, almost any Arduino will do, if you want to follow along at home. The next step was finding some kind of environmental sensor. My main concern was something that could detect CO2 and was not crazy expensive. I finally narrowed it down to 2, the ENS160 plus AHT21 and the SGP30. The ENS160 plus AHT21 is a combo sensor, and in addition to having a really catchy name, uses the ENS160 to sense CO2 and TVOCs, that's total volatile organic compounds, and the AHT21 to provide temp and humidity readings that can make the ENS160 more accurate. My second option was the SGP30, which I had heard good things about. It was slightly cheaper, but lacks the temp and humidity sensor, making the readings potentially less consistent. Upon receiving them, I was excited to get to testing. I tried out the ENS160 plus AHT21 first. Things looked promising, and I started getting readings, but then, suddenly, they stopped. I tried giving the sensor a pep talk, but that did not seem to work. That's okay, sensor. You go when you feel like it. I read somewhere online that this is a common issue, and you could potentially bring the sensor back to life by putting it on a hot plate. But after attempting to burn down my apartment by putting it on the stove, I gave up on that. That left me with the SGP30. I crossed my fingers, wired it up, and was relieved to see that after a brief calibration period, it started giving me consistent results. Breathing on it brought up the CO2 levels, and spraying some air freshener on it brought up the TVOC levels. The final piece of the puzzle was going to be some sort of motor. I settled on a regular old servo, which are great for applications where you don't need to move a lot, but you do need to be able to move to specific positions. After getting everything wired up, I just had to write a bit of code to tie the whole thing together. With that done, I had a basic prototype of what I wanted, that by itself already works pretty well to tell you about the air quality around you. And here's the diagram for the final electronics design. Of course I could not stop there, and I moved on to the next part of the plan, which was designing the plant. First thing I needed to do was figure out how to make it droop. I based my design off of classic thumb toys, which apparently you can only buy in packs of 12. The basic idea is that at rest, a spring pulls some strings taut and keep the figure upright. However, when you press the button on the bottom, they collapse like me when given a simple task.
Take out the trash!
If I can figure out a way to use the servo to press the button on the bottom, we are in business. I knew what I basically wanted, but I wasn't quite sure how to pull it off. I experimented with a few things before I settled on a mechanism. Basically, I take some fishing line, tie it to the head of the flower, and then have that line thread through some stem pieces. This fishing line is attached to a servo, and when the servo turns one way, it pulls the fishing line taut, makes the whole thing stand up. When it turns the other way, the line goes slack and the flower slumps over. With that settled, I jumped into Fusion 360 and started modeling. I started with the plant pot base. I modeled it so that it could hold the servo and the Arduino Nano, and still have room for the sensor and the wires. I also made this little attachment that goes on the servo so it can pull on the fishing line. Once that was done, I made a lid for the pot and whipped up these stem pieces. Finally, I jumped into Blender and created this cute little flower head. With everything designed, I sent it all to my 3D printer, and after just a few hours, I had all my parts. I soldered everything together and tested it all before putting it into the final case. Once I was satisfied it was all working, I tied my fishing line to the servo, threaded it through the stem, and tied it off to the top. I used hot glue to attach the head to the top part of the stem, and it was done. I plugged it in, and this was a fun project, and I learned a lot about 3D modeling and environmental sensors to get it done. I want to give a special shout out to Pam, Robin, and Christian for their support on Patreon. If you enjoyed this video and want to support me in making more projects in the future, Patreon is currently the best place to do it. That's all I've got this time. If you liked the video, a like is super appreciated, and subscribing will make sure you don't miss the next one. I hope you have a good one, and I'll see you next time here on Make It For Less.